Okay.
Next speaker is Marek Dudynski, a long-time collaborator of Konrad and friend. And he will tell you about different kind of research that Konrad was involved in.
Yes, it's completely different. I belong to the category that I am very long friend and life and stay, and also the collaborator. So I will, but quite different from the beginning, what was usually presented by the Krzysztof Mizerski. We have started, as he mentioned already, our first real collaboration with Konrad together with Christopher. The idea, before we start everything, I will try to explain myself also because I'm very happy to be there on this occasion. So I really want to thank Keith Moffat and also Andrzej Helczyński for inviting me and give me the possibility to show him a bit different face of the Konrad. Maybe not everyone really appreciates his interest in real life, because our work is very, very connected with real life. The first transparency will be shown because I'm a physicist, and we start our work, our life together in the Department of Physics at Warsaw University in the same year, because we started our study together. But after when we graduate, our life a bit goes in a bit different direction. He stayed in the university, and I go to the Center for Theoretical Physics to make my PhD in the statistical physics, and then diverge even more because he may take a quantum lab going to Cambridge, and I left in Poland, and after some time, very close when he was finishing his PhD, I start to go to the making industry. So I started my own firm, and my firm was developing industrial solution. We will show in the moment. And I was developing a big filter system for the chemical industry, and this filter is also developing the gasification for another kind of the industry. And sometimes we come together and I say, okay, we are both physicists. You are very active. I'm not in the moment maybe as so active. And what we can make together. The real idea is that we have working installation. In this working installation, the most important process you can imagine is hydrodynamics. But it is uncompromising hydrodynamics. It means you cannot make any simplification. You must take the life as the life goes on. It is a boundary, there is a very high speed, there is sometimes very high density. Usually in the biomass gasification you have problems which are also, it is working?
Yes, it is. Just the other button.
Oh, this one. Oh, so how it started in 1975, we met together with Marysia Ekiel also on the Department of Physics at Warsaw University, but in the 28 we make a first project, industrial project. We take encourage such, say, Krzysztof Mizerski to help go and make some calculation. We are applied for a grant. This grant was not given as it was mentioned. So we start in 2010 another project about the calculating, say, the burning of gas we are producing in the gasification system in the real life burning chamber, and to compare this calculation with the result we measure in the real life burning chamber. And this is the job which mainly was made by the Kamil Kwiatkowski, who made all this numerical calculation, with only our small help, to say the truth. But we are trying our best. And this is, I start with this is a picture taken in 84. This is the same year Konrad was going to Cambridge. It is our wedding time with my wife, and Konrad, as you can easily see, is there. There is interesting picture because we are, first of all, we are all young, and the second is showing that in this time there was completely different separation of the university, because we were looking for the men, and these all men are from the Department of Physics, and all women you can see are from the Department of Art History. So you see, there was no encouraging the women to go to the physics, and also the same with the men in the Department of Art History of the Warsaw University, but I believe in other university situation is very similar. So this is what we really started. It is a biomass gasification system I have produced. It is first, it was designed and produced, and this is a combustion chamber. To imagine what is combustion chamber, I will show you the real photo. This is a system where gasify the feathers. It is very difficult material to gasify. We only gasify and burn. And there is a burner. This is burner. It is something we say. There is a gasifier. There is inside. We see the flame. And what was the the purpose of, there is a different gasification system which is also contain the gas cleaning. The gas cleaning is a second problem you want to calculate, and there is still going on some kind of the system. There is a engine. When you clean the gas, you can put it into engine and produce, for example, electric energy and so on. There is a gas purification. This showing you all that also the numerical calculation for such a flow, where you have a hot gas flowing in one direction and different fluids, because there is a water or oil or other system, you want to purify this gas, to remove the tar out of the system. Also to make this real-time calculation is extremely difficult. It is something we all know. But start with this burning chamber. That is the result was obtained numerically by Kamil. There is one of the system which is quite interesting, but we are still working on it, because what is a real purpose, both experiment and calculation? I will show, because there is a nice system. When you have a burning chamber, and you put into the burning chamber the gas, hot gas and air. And for example, you are putting the gas there and the air there. So what you get a flame which have a shape. And this shape is usually going something like that inside the gasifier. And in this shape, which change in time, sometimes periodically, sometimes chaotically, you have places where you have a very hot temperature. If you have a very hot points where the temperature is very high, for example, is much higher than 102 degrees, you are producing enormous amount of the nitrogen oxygen. So our aim is to produce a gasifier which is completely uniform. We are not flame inside. We have only something which is similar to the boiling water. And we, with some combination, and then the temperature is uniform, we say 107 degrees, because 150 is obligatory, if we will be higher there. And we are, with the combination of the calculation which are made by Kamil, and with experiment we are making all the time, and this is a very big chamber, because there is a 20 meter high and 3 meter in diameter. So there, to calculate numerically something like that, it needs enormous numerical effort and a very, very big machine. And for example, to calculate for this gas, we take into account more than 140 chemical reaction. And we also full hydrodynamics and so on. And we are very closer to our aim to get some kind of the mild combustion, something that everything goes very smoothly and the temperature in the burning chamber is completely uniform in the whole big volume. So it is really showing such a calculation. You see the first stages, but then even the first stages 1 year ago, because there's a picture from the beginning of the coming work, it's showing you very interesting similarity between the calculation and the real picture taken from the burning chamber. So, apart of the calculation, we made together also with the very big organization effort of coming. Okay. Okay, I put it down. Thank you. So we organized the seminar for the students for the Department of Physics, Department of Chemistry, and also for the Technical University of Technical Warsaw University, which bring together different students on the discussion and work on the problems, the real problem of the gas burning, in the gasification, gas burning, gas process of the gasification, and also the impact of the different elements or connected mainly with the burning or gasification of biomass on the environment. This is also because Konrad was very, very interested in environment and impact of different elements. So we are trying to understand it. Among other things we make in this seminar, we started a proposal for the participation in the program for the doctoral study in the Marie Curie fellowship on the cloud dynamics. Now I am in this program and I am now looking for the solution for the cloud dynamics because the Szymon Malinowski, who takes the program from the university side, is now working with 2 international fellows, doctoral students, and we are making some influence, also the cabinet is also working on this. We want to introduce our elements connected with the biomass thinking on this cloud dynamics. I will come in the moment of this. So this is an element we made together with Konrad scientific collaboration, and one of the elements is understand with the Maciek Lewenstein from the ICFO Barcelona. We are making influence of the percolation phenomena on the behavior of the charcoal during the process of burning of charcoal, burning of wood. And also droplet formation, as I said before. There is a work of the group of the students. As I saw, we formed this seminar. This seminar is sometimes have almost 20 students participation, and different combination of the students are making. I show you several few of the example of this project we worked together. There was many students, some of them participation in this work half a year, some of them in 1 year, but they together, so we make some influence together with Konrad on the bigger part of the community than only university, because we are make this influence also on the people of the Technical University of Warsaw from different departments. So still I'm working with some of them because I'm still involved in this our technical problem, and some of them are still collaborating with me. Also the technical, purely technical problems, not only involving on the hydrodynamic of some calculation. There is a picture of the first group of this seminar. As you see, you can recognize Kamil on the front, Konrad, also the Karol, which was also the part of this seminar, was coming. There is a Marta Sosnowska, which was Maciek showing also on this picture, which Konrad on visiting the Cambridge. It was sometimes they were involved. So everything is coming in the family more or less, and very close cooperation. There is open problem we stay with our cooperation, and we are still trying to solve. First is that the dynamics of droplet formation. This is something which is common from the cloud physics, cloud hydrodynamics, and also hydrodynamics in the condensation of the gas from the gasification of water or gasification of molecules. The second, which is also very interesting and comes from our discussion, is a very important role which is not positive on the other kind of the biomass burning on environment. There is usually no thinking about when you burn biomass, wood especially. It is very easy but very popular in other kind because this chimney and wood putting, you are producing due to the depercolation process, which is very common in some moment. This when you are burning the wood simply disintegrate on the very small particles, and these particles contain soot, which are really fullerenes or graphene. This is also our new discovery that if you take the charcoal, 60 to 70% of the carbon atom are already in any charcoal in the form of the graphene, very small graphene plates. When this disintegrates, all this graphene goes to atmosphere, and you really it is very difficult to understand the influence on the carbon in atmosphere, not CO2, but this carbon in the particle form. You can imagine 1 gram of the soot in atmosphere during the one day takes 3 million kilocalories of energy. It is enormous, 3 million, enormous amount. It is a main source of heating on the clouds. Or I made some calculation, and I believe that almost 30% of the warming of clouds are coming from the carbon, not only from the CO2. So looking for the influence of the other kind of the biomass burning on the atmosphere, on the global warming, must be very important new aspect of the science. So, for example, I'm showing we make a photo on the electronic microscope. These sheets are the graphene elements in the charcoal, on normal ordinary charcoal. There, for example, this is so-called the graphene cone. They are forming when you are freestanding graphene, which are broken in one point. So this freestanding graphene automatically take a cone. And you see there are very many cones made of graphene in normal ordinary charcoal you are made or you bought simply for your barbecue. So this is a picture you make and you recognize it. It is last our meeting together when he was and I visited him. We are sitting there making some plans what we made together in the future, also on this process which I will describe, because most of this work, I believe in this last year, many part of his interest was connected with this real life calculation and use of hydrodynamics to industry or this work we are made together. I'm very, very proud that I was working with him and also very happy that we are working still and get such results which are very important as you see, because they are all results which have a future, so they need a future work and to development. I hope still that this student I started during this cooperation, they will be working with me and we get some future results. So I believe this is enough. So thank you very much for your
I have a curiosity. how graphene particles do affect condensation as
Yes,
well.
yes, there is a
No,
very
apart
deep,
from warming.
yes,
apart
yes,
from
yes,
heat.
also the condensation, but there is a physically very difficult process to make a real calculation, because how to calculate relation between the graphene plates and the water, for example. There is also the physicists. It is a very interesting process because we are making. There is, as yeah, I am not mentioned because there is also the similar, but there is a very straight now, as I found, connection between the electric and magnetic properties of the charcoal and the Klein effect in elementary, because there is no Anderson localization, and this lack of Anderson localization in the graphene elements are connected with the Klein effect. So there is a relation between the proper piece of wood and the very elementary, very advanced, very theoretical physics, connected with the electrons, Klein effect, and so on. But the calculation, real calculation of the influence of graphene is a very advanced problem we have not started to do. How to really, because there is a single atom plate, very small, and how to calculate influence is very difficult. Yeah.